Hello everyone. Me and my group mates will discuss a published agricultural study of aldehydes, ketones, carboxylic acid, and esters. And a published agricultural study that we're going to discuss is all about the investigating of aldehydes and ketone compounds produced from indoor cooking emissions and assessing their health risk to human beings by Wei Zhang and Li Wang.
Effect of heating different edible oil on aldehydes and ketones emission. Fig 2A and Appendix Table A, Table S1 to S5 show the average concentration and emission factor of aldehydes and ketones from heating 5 different edible oil. The emission factor of aldehydes and ketones produced during heating rapeseed oil was the greatest, reaching up to 436.12 oil in comparison to the lowest value of 250.87 oil for the emission of heating lard. The emission factor of aldehydes and ketones for rapeseed oil was 1.74 times of that for lard among these 5.
Abstract. Aldehyde and ketone compounds are ubiquitous in the air and prone to adverse effect on human health. Cooking emission is one of the major indoor sources, aiming to evaluate health risks associated with inhalation exposure to aldehyde and ketone compounds. 13 carbonyl compounds or CCS released from heating 5 edible oils, 3 seasonings, and 2 dishes were investigated in a kitchen laboratory. For the scenarios of heating 5 types of oils, aldehydes accounted for 61.1% to 78.0% of the total emission. Mainly acetaldehyde, acrolein, and hexanal. Comparatively, heating oil with added seasoning released greater concentration of aldehyde and ketone compounds. The concentration enhancement of larger molecular aldehyde was significantly greater. The emission factors of aldehyde and ketone compounds for cooking the dish of chili fried meat were much greater compared to that of tomato fried eggs. Therefore, food materials also had a great impact on the aldehyde and ketone emission. Acetone and acetaldehyde were the most abundant CCS in the kitchen.
A large proportion of aldehydes and ketones have strong irritation and toxicity to human health. Long-term exposure to high concentrations of aldehydes and ketones can lead to dizziness, nausea, and other symptoms, which is harmful to human health, and a previous risk analysis suggested that aldehydes accounted for over 91% of the total risk of non-cancer diseases, including cardiovascular and lung diseases. Compounds such as acetaldehyde and acrolein can cause chronic and acute damage to human respiratory system. Acrolein is also an eye irritant that worsens asthma, and a recent study showed that a long-term inhalation of acrolein, even at low levels, may increase the risk of cardiovascular disease. Acetone is a medium toxic reagent which damages a central nervous system and liver to human. Given adverse effects of aldehydes and ketones, human exposure to aldehydes and ketones generated from COF can lead to potential health hazard. However, this only sets the reference value from formaldehyde, and although the number of studies have investigated personal exposures and health risk of aldehyde and ketone compounds inside cars, public transportations, and indoor living rooms, and less attention has been paid to human exposure to aldehydes and ketones inside kitchen during cooking.
Sections Nitrates Kitchen Lab. A kitchen laboratory was built to study aldehyde and ketones compound generated from COF released from various cooking process. The size of the kitchen is 2.5 m in length, 2.0 m in wide, and 3.0 m in height as given by figure 1. The cooking area was 1.0 m above the ground. An induction cooker with 1,600 watts power was adapted for heating edible oil and cooking dishes. A temperature monitor was used to monitor the temperature during cooking and aiming to maintain the temperature varying within ketone compounds.
Aldehydes and ketone compounds are ubiquitous in the air and prone to adverse effects on human health. A large number of previous studies shows that primary pollutants such as motor vehicle exhaust, industrial emission, and catering oil fume are important sources of aldehydes and ketones in urban atmosphere. Comparatively, the typical source of indoor aldehyde and ketone compounds mainly include the release of architectural and decorative materials. Smoking and indoor cooking oil fume consider that is conclude sometimes in indoor air quality is worse compared to outdoor air quality. People spend over 80% of time indoors, and CUF is one of the major sources of indoor aldehyde ketone compounds. It is necessary to understand and evaluate the concentration level of aldehyde and ketone compounds in the kitchen, microenvironment, and human exposure, which is useful to assess the health effects on CUF-related aldehyde and ketone compounds inside kitchen and other rooms.
Conclusions. The result of the study indicate the types of edible oil and seasonings had different impacts on aldehyde and ketone emissions produced during cooking. For only heating 5 types of oils, aldehydes accounted for 61.1% to 78.0% of the total emission. Mainly acetaldehyde, chlorine, and acinal, the emission factors of aldehydes for various edible oil range from 153.19 to 299.79, with the order of sunflower seed oil, soybean oil, rapeseed oil, peanut oil, lard this difference.